Section 11.6, we're talking about proportions with volume. Yesterday, proportions with area. Today, proportions with volume. So in example A, the question is, are these right rectangular prisms similar? That the two prisms are not similar because the corresponding edges are not proportional. And as we can see, one ratio is 2 over 2, which equals 1, but then the other two ratios both equal 1/2. Not proportional, therefore not similar. Example B, are these right circular cones similar? The two cones are similar because the radii and heights are proportional. 8 over 12 equals 14 over 21. Find the volume of each cone and compare the ratio of the larger cone to the smaller cone with the ratio of the radii and heights. How do they compare? So we know from the previous slide that the ratio of the radii and heights, we had, what do we have? 8 over 12 was equal to 14 over 21, and those both equaled 2/3. So we need to now calculate the volume of each cone and compare it to the ratio of 2/3, right? So the volume of a cone is 1/3 the area of the base, which in this case is a circle, so that's pi r squared, times the height of the cone. And if we're finding the volume of the little cone, I'll do L for little, 1/3 pi times radius of 8 squared and the height of 14. So if we simplify this, 8 times 8 is 64. So we'll keep this 896 over 3 pi. And now let's find the volume of the big cone. So we'll go VL was for little, VB for big. And we'll have 1/3 pi radius of 12 squared times the height of 21. So the volume of the big cone, 1008 pi. So we take the ratio of the volumes. We want little over big because we did little over big down here. So 896 pi over 3 over 1008 pi. So the pi's will cancel out, right? So we need 896 over 3 divided by 1008, or we need to simplify that ratio. So to simplify this, if we're dividing by 1008, that's the same as multiplying 896 times 1 over 1008, which would result in 896 over 3024. Simplifies to 8 over 27. So now we need to compare 2/3 and 8 over 27. 2/3 cubed is 8 over 27, right? 2 cubed, 2 times 2 times 2 is 8. 3 cubed, 3 times 3 is 9, times another 3 is 27. So we see the relationship here. If we take the ratio of the radii or the heights or the sides, whatever type of shape we're dealing with, and we cube it, we'll get the ratio of the volumes. And that's exactly what the proportional volumes conjecture states. If corresponding edge lengths or radii or heights of two similar solids compare in the ratio of m over n, then their volumes compare in the ratio m cubed over n cubed, or m over n cubed.